Hello, so in this video we're going to go over the review for the final for Stats XL10. So let's go over the first problem. So first let's read what the problem is asking us to do. So it says read the following problem description, then choose the correct null and alternate hypothesis. A new drug is being tested to see whether it can reduce the rate of food-related allergic reaction in children ages 1 to 3 with food allergy. The rate of allergic reaction in the population of concern is 0.03. So for this one, we're doing the rate, so it's a proportion, so that way we have P instead of mu. So that way we have this P, so this P. So all number one is asking us to do is to do a null and alternate hypothesis. So if you remember about the null hypothesis is always stating there is no change. So that way, if we just look at B, did not want to do that. If we look at B has a not equal sign for the null hypothesis. So we know it can't be B because the null hypothesis is always stating there is no change. So it should always be an equal sign. Same thing with A. A has P is less than 0.03. So that we kind of want to take that one out of the running. All right. So we're down to C or D. So C, if we look at it, it's saying that P is less than 0.03, and D is saying that P is greater than 0.03. So what we want to do, we want to look for keywords. So right here, the keyword is reduce. So reduce meaning that if it should reduce, it should make it, instead of it being the ratio being 0.03, it should be less than 0.03. So that way for this one, your final answer should be C, that the null hypothesis is that P is equal to 0.03, and the alternate hypothesis is that P is less than 0.03. Alright, so if you look at 2 is exactly the same problem, so we could just skip that one. Alright, so let's move on to number 3. So for number 3, say a claim is made that the proportion of children who play sport is 0.5, and the sample statistic of 1,327 subjects with 30% saying that they play a sport. So if you look at the bold instruction all the way on top, it is asking you to find the Z value or the test statistic. So the key thing that you want to notice here, they're talking about proportion. So since they're talking about proportion, we want to use the formula for the Z that is for proportion. So if you remember that is, well, first thing you want to find is standard error, where standard error is just P times 1 minus P all divided by N. Alright, so I'm going to blow this up a little bit. Guess I can't do that. So what we want to do, this is P is a proportion of the claim. So the claim is that 0.5 or 50% of the proportion plays sport. So instead of putting P, I'm going to put 0.5, 1 minus 0.5, all divided by N. So N is how many subject matter we have. So in this case, we have 1,327. So 1,327. All right, so what we want to do, we want to calculate that. So let's get a calculator. Wait. All right, so let's clear this. So for this one, let's calculate standard error. So we're going to put second square root 0.5 times 1 minus 0.5 all divided by 1,327. So for this one, kind of good if we go 3 decimal places. So we're going to go 0.013. Well, instead of going 1.3, let's actually do 0.014. Okay, if we use the 7 could round up the 3 to 0.014. So that's standard error. So once we get that, we're going to get the z value by using this formula where we do p hat minus p all divided by standard error. So in this case, p hat is whatever proportion they got from the sample. So the proportion they got from the sample is 30%. So you always want to convert that to decimal. So we'll put 0.30 minus the proportion of the claim, where they're claiming that the proportion of people who play sport is 50%. So we put 50 right there, and we divide it by standard error. So now if we do 0.30 minus 0.50, that will give us negative 0.2. And then we divide that by 0.014. And we get negative 14.29. So this is our z value. So if you look at it, it can't be A, it can't be C. B is pretty close, but you have to pay close attention that this is a negative z value and this is positive. So our final answer should be D, that z is equal to negative 14.57. Alright. So let's do number 4, and then that'll end the video for the first 4 problems, and then we'll do a new video for the next following 4 problems. So for number 4, it says, use the following information to answer the question. A janitor at a large office building believes that his supply of light bulbs have a defect rate that is different than the defect rate stated by the manufacturer. The janitor's null hypothesis is that the supply of light bulb has a defect rate of P is equal to 0.09. The light bulb manufacturer state defect rate. Suppose we do a hypothesis test with significant level of 0.01. Symbolically, the null and alternate hypotheses are follow. So it said, choose a statement that best describes the significant level in the context of the hypothesis test. So for this one, they wanted to describe the significant level. So it's kind of significant if we know what the significant level represents. So the significant level could also be represented as alpha, and it also could represent a type 1 error. So a type 1 error is when we reject the null hypothesis. So reject the null hypothesis. So we reject the null hypothesis when the null hypothesis is true. So what we want to do, we want to look at number 4 and see which one kind of best demonstrate that. So remember, so in the context of the problem, it means that we reject that the proportion of defect light bulb is 0.09, and we conclude that the proportion is actually greater than that, but in actuality, we should have never rejected that. Alright, so A, it says the significant level of 0.01 is the z statistic that we will use to compare the observed outcome to the null hypothesis. So that one's wrong. B, the significant level of 0.01 is the probability of concluding that the defect rate is equal to 0.09 when in fact it is greater. So B is actually describing a type 2 error. Because the type 2 error says that we failed to reject the null hypothesis when the alternate hypothesis was actually true. So if we wanted the type 2 error, B will be correct, but since we want type 1, B is incorrect. So C says the significant level of 0.01 is the probability of concluding that the defect rate is different than 0.09 when in fact the defect rate is equal to 0.09. So this one kind of hit the trademark of a type 1 error, Because it's saying that we conclude that it's different than 0.09, but in actuality, it's still 0.09. So that way, for this one, C will still be C will be correct answer. All right, so that's it for this short video for question 1 through 4. So we'll end it right there. Let's see.